Hi, everyone. My name is Gregory Chanan. I am a software engineer at Cloudera, and today I'm going to talk about secure Solr with Apache Sentry, or integrating Apache Sentry with Solr to provide some security features. A little bit about myself. As I mentioned, I'm a software engineer at Cloudera, also recently an Apache Solr committer, Apache Sentry committer, which is a project in the Apache incubator. So this talk is kind of be the intersection of those two things. I am also an Apache H-based committer. So overview of what we're going to talk about, kind of give some motivation for why security with Solr and Solr Cloud, specifically why Apache Sentry to provide this security. Then what security features does Sentry add, specifically around authentication and authorization. And then finally, we'll talk about secure impersonation a little bit, also about performance and a little bit of future work. So to start, to understand kind of why the motivation behind Apache Sentry, we need to understand kind of what the current state of the world is in Solr. And so these are kind of some quotes taken from the Solr security wiki. So today, Apache Solr provides only minimal security features. If you read this, it says like, any client with access to Solr can add, update, delete documents, access configuration, administrative interfaces. In the past, the recommendation when Solr was deployed as a single server is that the application server containing Solr be firewalled such that the only clients with access to Solr are your own. So that's kind of the current state of the world. In our work at Cloudera, which is mainly in like the big data Hadoop space, we see the Solr Cloud feature kind of driving adoption of Solr in this space. And so for those who aren't familiar with Solr Cloud, this is basically just Solr running in a cluster. So it's using Zookeeper here for coordination and configuration, storing data in HDFS, maybe indexing data via MapReduce, like data stored in HDFS can be indexed via MapReduce. So the typical setup will already have a Hadoop cluster with all these things on it, right? So what most people do will add Solr on top of this rather than spin up an entire new cluster, which isn't economical. So now Solr is just a component of a multi-tenant cluster, and so the kind of assumption or argument in the previous slide, which is like firewall Solr off from everything, doesn't really apply because you have a bunch of users on this cluster, like maybe they're running Hive jobs or MapReduce jobs or whatever. Also, Solr itself is communicating across machines and services. So like, the data that's stored in HDFS needs to be secure. The data that's stored in Zookeeper needs to be secure. So when you're now in this like cloud-based model or whatever, there's kind of more things that need to be secure. So why Apache Sentry? So Sentry is already established in the Hadoop ecosystem. It already works with both Hive and Impala. These are kind of database level products. It has an understood authentication model via Kerberos. I'll talk about that in a bit more depth. It also has an understood privilege and action model that's extensible. So with Hive and Impala, this is database focused. So you'll say things like, grant users the ability to select on a table or delete a row or something like that. But this model is extensible enough that you can basically define your own model, define your own actions. So when we're talking about Solr, this will say things like, give this user the ability to query a collection foo, right? So Sentry is a security-focused project, so kind of basic breakdown of responsibilities, or however you want to phrase it, is Solr is focused on being a search engine, and Sentry is focused on the security aspects. Okay, so that's kind of motivation now. What does Sentry provide if you integrate with Solr? First thing is authentication. So authentication, for those who are not familiar, or even those who are, authentication is verifying the identity of a user or a service. So Solr already supports authenticating with its dependent services. So like it stores data in HDFS. It already supports authentication there. It stores data in Zookeeper. It supports some authentication there. I put a star there because I think there's some more work to do. But Sentry's goal is kind of in the opposite direction, which is things that are dependent on Solr need to authenticate with it rather than in the other direction. So consistent with the other HTTP level Hadoop services like Uzi or Hadoop HTTPFS, for people who are familiar with those, Apache Sentry uses this combination of Kerberos and Spinego. I won't go into a ton of details on these, but just like at a high level, Kerberos is a mutual authentication protocol that works on the basis of tickets. And Spinego is a negotiation mechanism for selecting a protocol. So if you connect with Solr, like with curl, and you turn on verbose mode with Spinego and Kerberos running, you'll see this whole like negotiation pattern happening at the beginning, and then eventually it'll look just like it did before you actually use Kerberos. So the advantage of using Spinego and Kerberos is basically that the HTTP tools that you already use to contact Solr, the vast majority of them already support this. So like you can configure your web browser to use Spinego and Kerberos. Curl supports it with -- negotiate. A bunch of HTTP libraries like Apache HTTP client, which is actually used by SolarJ, which is the Solr Java client, have support for it. And so that'll come in later. I should also note that although Kerberos is an authentication protocol, not an authorization protocol, you can get kind of like poor man's authorization by only granting Kerberos credentials to the users who should have access to Solr. So obviously this can't give you like fine-grained access control, but it can give you cluster-level access control. Okay, so setting this up, on the server side, you basically we provide a web XML, which has a Kerberos Spinego aware filter. You're responsible for doing the standard Kerberos setup in the Java world, which is like key tabs and principals and Jazz configurations. On the client side, kind of similar, we provide an HTTP client that is configured for communicating with Kerberos and Spinego. Again, you have to set up the key tabs and principals and Jazz configurations. It's a quick like product plug. Anyone who's set up Kerberos on a cluster will probably tell you it's pretty painful. I see some people nodding their heads. So one cool thing is that Cloudera Manager can set this up for you. So it's just like a simple toggle box. You say, I just want simple authentication or Kerberos authentication. It will set up the key tabs, the principals, the Jazz configurations for you. So you can just worry about your application rather than bang your head against the wall trying to set this stuff up. Okay, that is authentication. Now I'm going to talk about authorization, both at the collection level and the document level. So authorization is typically used after authentication when you know who a user is, and now you want to control access to different resources. So again, Solr does not provide collection or document level authorization out of the box. What it does provide is what I've termed as like hooks, in that it's basically infinitely configurable. And so Solr provides a bunch of configurations that out of the box provide this kind of thing. So if you're familiar with like the Solr config files and Solr.xml, we have our own versions of those that we ship. So how does this look like? At the collection level, we support role-based granting of privileges. So each role can be granted query, update, or administrative privileges on a collection. Today, this is defined. These privileges are defined in a policy file, which is typically stored on HDFS. This policy file has two different sections. The first one is called groups, which is responsible for assigning each Hadoop group to its set of roles. So I've come up with like a super contrived example here, but we have a DevOps group, and that belongs to the engineer role and the ops role. How the group mapping works is also configurable. By default, it's just the Hadoop groups, but there's different plugins you can use. Then the roles responsible for mapping each role that you've defined here into the set of privileges. So in our example, the engineers can both query and, I meant to acute an angle, update the source code collection. And then the ops role similarly can query the HBase logs collection. Kind of simple setup. Yeah. So how do we integrate this? I already mentioned that we ship our own solrconfig.xml. So here's a typical HTTP request, comes into Solr, hits the Solr dispatch filter, which then sends it on to the correct request handlers. And these request handlers are defined in Solr config. So based on the path, if it's /select, you'll send it to the Solr search handler. So we just have a set of standard Solr request handlers that we have augmented to do the Sentry security checks, basically. So as an example, we'll talk about the select request handler. We use a component, what's known as a component to answer the question, is the user allowed to query this collection, based on the policy file defined in the previous slide. And if no, we throw an exception back to the user, and say you're not authorized to view this collection. If yes, it just continues on, and it looks like you didn't have security set up or whatever. Okay, so that covers queries and updates. What about administrative requests, which we haven't talked about? So in Solr, the admin requests kind of just look like any other collection. So that's where like a collection name would be in a normal select request, right? So Sentry just follows this structure exactly. And so it says, for the admin collection, give me query access. And so if I wanted to make a request like getting the status of all the cores, which this thing is doing, then that's the permissions that you need. So similarly to the previous slide when I was talking about providing our own solrconfig.xml, we provide our own Solr XML, which is kind of cluster-wide configuration. So basically identical setup. And so for the request handlers that we ship and all the different actions on those request handlers, we've defined what permissions you need. So that's available on the website. You can't obviously click that now, but here's just an excerpt. So like if collection 1 is just some arbitrary collection name, to select you need query, to update JSON you need update on that collection, to view the thread dump handler you need query permissions on the admin collection. And so you can go to the website and there's like lists and lists of tables of what actual permissions you need. So obviously if you've kind of implemented your own request handlers to do some application specific thing, this won't work with Sentry out of the box, but it's fairly easy to integrate. You can see how we've modified the configuration files, and it's pretty simple to just combine the two things. Okay, that is collection level authorization. Now I'm going to talk about document level. Okay, so collection level authorization is useful when the access control requirements for documents in a collection are homogeneous. So that's not always the case though. Sometimes you might want to restrict access to a subset of documents in a collection. So again, I'll come up with a trivial example, which is just I have confidential documents and secret documents, and secret is more secure than confidential. So how should I store these documents given that I only have collection level authorization? There's a couple ideas here. One is I could store them separately in 2 separate collections, but then my application needs to combine and score the results. And so I've pushed some complexity there. Alternatively, I can store confidential docs and confidential and secret docs in one collection, but now I have more storage. I have a data management problem if I ever want to modify the documents. So again, I pushed some complexity to the application. So the idea behind document level authorization is that Sentry should deal with the complexity, not your application. So instead of a policy file stored in HDFS like we had for the collection level authorization, we store authentication tokens in each document. The reason for this is fairly straightforward in that if you have 100 million documents, it just won't scale to have 100 million entries in your policy file. Also, we can use Solr's built-in filtering capabilities to actually implement this. So I'll talk about the implementation in a bit. So the way this works is you configure a field to store the authorization tokens, and then the authorization tokens themselves represent the Sentry roles. So if you refer back to the policy file, we define a role, an ops role here. And so we would put this as a value in the configured field. And then the way that works is basically defined here. To view a document, the querying user must belong to at least one role whose token is stored in the token field. So a few implications of this. Obviously, we can modify the document permissions without restarting Solr by just updating the documents. If we want to change role memberships, also, we don't necessarily have to re-index to change all the token fields. What we can do is we can change what users belong to what groups, and that's just evaluated at runtime. Then the second level is we can change what groups belong to what role, if you refer back to the policy file. So that currently does require restarting Solr, although we're working on that, but it does not require re-indexing. So we've tried to make it, enough levels of indirection that you don't have to re-index often. So this is implemented in a similar way to the collection level authorization. Basically just stick on a filter query at the end of ORing all the users' roles together. The actual filter query that we use is a bit more complicated, but that's the basic idea. So the end result of this is that you filter out all the documents that don't have one of the user's roles tokens on it. So from the end user, it just looks like those documents don't exist. You don't get error messages or anything. It just looks like there's fewer documents than there actually are. I should note that it doesn't supersede collection level authorization. You can see we have this collection level component here. So even if according to the document level rules, I can view a document, if I'm not even allowed to query the collection, then I'll get an error and we won't spend any compute actually doing this. So here is what the configuration section of the Sentry provided Solr config looks like. It's pretty straightforward. You can enable, disable document level authorization. You can define the field where the tokens are stored. There's also something known as an all roles token. So the implication of does this work? The previous rule is that to view a document, you must belong to at least one role whose token is in the document, is that if you have no tokens, no one has access. So this all roles token idea is useful for a couple of scenarios. So consider you actually have this requirement where anyone should be allowed to see this specific document. If you didn't have this sort of token, you could put all the roles in the document itself. That would be a pain, especially if you added new roles in the future, right? You'd have to keep that up to date. The other is often you're not coming from a clean slate world. You might already have a Solr setup and be like, hey, I want Sentry to provide security with this, but I'm not sure exactly what my roles are. I haven't figured everything out at this point. So what I can do is just start by putting the all roles token on every document. In that way, I'll have the same behavior as before, but now I can kind of refine things as I go, as I figure out who should belong to what groups, what set of documents should be viewable by what groups, etc. Okay, that is document level authorization. Now, secure impersonation. So some people right now might be saying, hey, that sounds cool, but this actually isn't going to work for my setup because my end users don't actually talk to Solr directly. Maybe I have a load balancer in front, maybe I have a web UI, a custom web UI in front, and so I'd have a setup like this where my end user is authenticated to the web UI as user, but then my web UI is authenticated to Solr as UI. So then it looks like all my requests are coming from UI and it can't actually do authorization. So secure impersonation is a feature designed to address this. At a high level, it's the ability of a super user to submit requests on behalf of another user. So you can kind of think of it as conceptually similar to sudo on Unix. It is limited to only the groups and hosts that are explicitly configured to support it. So in this setup here that we've kind of defined, what you would do is you'd say, UI should be able to impersonate user and any other groups that would be communicating with the web UI, and he should only be allowed to do it from this host that I expect. And so then the way this works is we basically add this parameter into the HTTP request, which is do as user. Solr sees that. Okay, I'll give up on that. Solr sees that request, does the checks that, is this actually configured that way? And then if it is, for the rest of the request lifetime, Sentry sees the request as actually coming from user rather than from UI. So this is identical functionality that's provided by HDFS and Uzi, if you're familiar with that. So we're not reinventing anything here. This is tested and all that. So as an example of this, there's the Hue search app UI. I think Romain gave a talk on this earlier today. But basically what this does is uses secure impersonation to integrate with its own security mechanisms. So you can log into Hue via LDAP or any other authentication mechanism. If you see here, you probably can't see, but there's Romain is logged in there. And Hue makes requests on behalf of whoever the logged in user is using that secure impersonation feature. So the advantage of that is the only key tab for Kerberos that you need with this is Hue, right? If Hue itself was trying to, let's say, make requests on behalf of the actual user instead of using secure impersonation, you'd have to give Hue access to all of the user's key tabs, which would just be a huge pain. So, with a setup like this, you seamlessly integrate with the collection and document level access control mechanisms. So if you haven't checked out Hue, I recommend it, but you could do a similar thing if you have your own custom web UI or a load balancer or something like that. Okay, performance. I'll probably go through this quickly, but our goal is to measure separately the Kerberos authentication overhead and the collection level authorization overhead. I didn't measure the document level stuff on the same machines just because I did this earlier, and document level security is a newer feature, but its results are pretty similar. So we're going to measure both the index and query overhead separately. So here's the index test setup, 20 node cluster, 260 million tweets, index across 17 fields, 116 gigabytes. Okay, that's fairly standard. The interesting thing to note about this is we're using the MapReduce indexer tool contrib, which doesn't index directly into Solr. It builds an offline index and then merges into Solr. So the actual amount of Solr work here is very small. So I'm just using this as like a sanity check to show we're not doing anything crazy, not some super detailed performance test. So we see this is some normalized results. So just the MapReduce batch indexing time we're defining as 1. We see just HDFS authentication on using Kerberos is like a 20% overhead. And then turning on Sentry as well is basically the same performance, which is about what we'd expect given the amount of actual Solr communication we're doing is very small here. So again, just a sanity check. We're not doing anything crazy. Query test setup. We're basically querying the results of the batch indexing job here. Uses our own internal tool, which is similar to like Solr meter, JMeter, if you've seen those. It's randomly sampling from a fixed set of 10,000 strings. So here, pretty similar, like 13% overhead for HDFS authentication. It's actually a little strange that Sentry is better than when it's turned off. I wouldn't take that seriously. I would just take it as we didn't do very many trials and it's within the error bounds. So, so very little overhead. Okay, future work. So there's a few different things going on upstream in Sentry right now. One is support for a Sentry service. So This is already supported for Hive and Impala, provides better APIs, so you can't have like syntax errors in your specification like you can with just a flat file in HDFS. Better performance, it's database back instead of a flat file that we need to read in a bunch of times. So integrating with Solr is currently in development upstream. Oh, another thing I should mention is integration points. So Hue, which is the web UI that I mentioned, is working on a permissions UI. So you can define, I want my Hive permissions to look like this, and I want my Solr permissions to look like this, and such. And so that would work with the Sentry service. The other thing, which I view as kind of the holy grail of Sentry, if you will, is what I would call lineage security. So there's all these different systems in the Hadoop ecosystem, right? Like, as one example, I might index data from HBase because I want to do full text queries, and HBase only allows primary key lookup. So the HBase already has some security levels defined at both the table level and the cell level. Like, wouldn't it be awesome if when I did that index, those same permissions were just automatically applied to the data in Solr, at the collection level, document level, field level, whatever was necessary to actually implement this. And so, as an administrator or as someone ingesting data into the Hadoop ecosystem, I could just define what permissions are on this data once and not have to configure kind of every service separately, which you kind of have to do today. So we're definitely not there, but that's what I would view as kind of the end goal of this project. Okay, thanks for listening. You can find a bunch more information on the Sentry website, which is in the Apache incubator. I think I have a couple minutes for questions. Yeah.
For document level authorization, how do you handle changes in the rules to a document that people complete? Do you have to re-index all of your data?
Yeah, so I covered that a bit. Sorry, the question is, how do you handle changes to permissions and such? So the answer is it depends on what kind of change you make. If you're actually changing what roles are allowed to see the document, then yes, you have to re-index. If you're changing, if you're worried about specific users, you can do things like change what groups the user belongs to and what groups are associated with each role, and that does not require re-indexing. But again, it depends on what kind of change you're making. Yeah.
What's the difference, if you know, the distinction between Apache Sentry and Apache Knox and Ranger? They both seem to offer the same sorts of security capabilities.
I'm not that familiar with with these other projects. I haven't heard of anyone else doing collection and document level security. I know that they're doing like authentication, but I could be totally wrong. I don't know very much about them. Yeah.
Do you utilize LDAP servers for your authorization?
Yeah, so you can do that directly via, sorry, the question is, can you use LDAP for authorization? So you can use Hue directly because Hue can integrate with LDAP. What you can also do is, when you're defining the groups, so I didn't actually show this, but when you're defining these groups, you can define how the groups are resolved. And so like by default, you use Hadoop groups. You could also use what's called shell groups, which is just, Linux groups, basically. I believe that there is an LDAP plugin for that can use LDAP groups. But that's the extent, is you can define the groups and you can use Hue. Okay. Does that make sense?
Is there any intention to support field level authorization? I can see a document, but I can't see this field in that document.
Yeah, so the question is there, are you looking at support to field level security? So I can, similar to the document, I can see the document, but I can't see the field. It's on the roadmap. We haven't seen a ton of need for it at this point, but if people are interested, that's something we definitely look at. And I guess I'm out of time now, but you can come up to me after if you have any more questions. Thanks for listening.